What's good, everyone? Going to continue on with the SageMaker Inference and hosting series today. And what we're specifically going to explore is an approach known as bring your own container. Should have probably spelled that out on the title page there, but that's what BYOC, if I refer to that, stands for. And this is a method that's sometimes needed if you're working with SageMaker Inference and you have a very customized model serving approach. And we'll explain exactly why and when to use it and how you can implement it. And as always, we'll get hands-on with a demo, and in this case, we'll take a pre-trained scikit-learn model, similar to what we've been working with, but like always, you can kind of adjust and adopt it for your use case. So let's get right into it. Let's hop into the iPad screen for a little, and let's explain what BYOC is. And before we can even get there, if we remember within SageMaker, and I encourage you to revisit or rewatch, or if you haven't watched yet, how containers work with SageMaker video, just to get more understanding and maybe a bit of a longer explanation here. But we'll quickly go through it and explain what's happening here. Within SageMaker hosting, if we remember, there's a few things that we need to bring to be able to deploy it. There is model data, which is your serialized model artifacts. Like we know with scikit-learn, it might be a joblib file, a pickle file. Within Torch, it might be a .pth, things of that sort, right? This model data is basically capturing the state of your trained model and allows for you to do inference. So anytime you train a model, you need these serialized model data artifacts that we're going to be using on a hosting platform such as SageMaker, or even your own self-managed platforms such as EC2 or EKS or anywhere else you might be working, right? So you need a model data, and then you need a container. And this container, as we talked about, provides the runtime environment to serve these models. And it implements a model server or something of that sort. And examples of model servers, as we talked about, are Triton, Torch Serve, DGL serving, which Amazon came with and that we've used in this series. And then there's different ones even for LLM, such as VLM and things of that sort, etc., right? You get the point there. Basically, that model server is what will help expose this as a REST API and help load your model. And the container is basically what implements that and encapsulates that, right? And provides this runtime environment to execute different types of models such as scikit-learn, PyTorch, TensorFlow, whatever framework you're using, Hugging Face, whatever you might be working with. But this container prepares that runtime environment by implementing that model server and then also having that runtime environment ready for you by installing whatever dependencies you might be working with. The power of SageMaker, right, or that really kind of simplified deployment that we talked of, is there's many available managed containers provided for you by SageMaker itself. And that's what we've done when we point towards that DGL CPU image. We simply pass the ECR public URI to that, and that's completely managed by AWS and taken care of for you. And this saves a lot of time because you don't have to worry about like container patching, any kind of updates. They release later containers. So if there's a version of, for example, DGL, a later or older version, there's a newer version that will be then released with the latest updates, any patches, any bug fixes, and any updates that you can think of. So for example, VLM, right? There might be updates as it's an open source technology. What AWS does is it comes with the LMI container backed by the DGL serving, for example, that comes with the later versions of VLM, TRT-LLM, things of that sort. So these available and managed images is a very easy way to get started with SageMaker Inference, because as data scientists, we don't really want to deal with building a Docker file or things of that sort and kind of setting up the serving stack. And it simplifies and saves a lot of time there. But in some cases, you will need your own image. And let's just call this a custom image for the sake of simplicity. And you'll need this depending on a few cases. You might need a custom image if, number one, you have your own proprietary, holy, I must have butchered that word, proprietary, whichever way you say it, your own kind of images or dependencies that you have to work with. So sometimes, especially if you're in a corporate setting, your company has a certain base image or something that needs to be used, you kind of go this route where you need to be able to bring your own Docker file. Because in reality, right, this is at the end of the day, these are publicly available images via something known as ECR, which is the Elastic Container Registry. You can think of this just as within AWS where you store your images. But these are public ECR images. And for companies that might be a little tighter on the security side or things of that sort, right, or have their own kind of base Docker files base Docker images that they need to work with or anything of that sort, or any company specific dependencies or any kind of security protocols that force you to use a custom image, you are going to go this route basically. And then there also might be cases, right, where you actually do something known as extending an image. Maybe you like to try an image and your company allows you to use it, but you need to add XYZ dependencies to it, including maybe some custom module that your company's developed or something of that sort. So you can use these AWS images as base images still, or you can use your own custom one, as we were talking about, or if there's a preference for another kind of Docker image that you'd like to use as your base, you can do that, but you can also extend an existing AWS one if you're compliant and able to do that too. And on that, you can install whatever other dependencies, because these managed images that come, they have a set list of dependencies that are already installed, but that might not capture everything you have. So for example, let's say for Spacey, right? That's a NER kind of library that's out there. There's no image that comes pre-installed with it. So what you can take is you can take the base kind of image that you might be working with and install that on top of it. And SageMaker makes this simple where this approach, once again, is known as bring your own container. And for this, right, the actual implementation, kind of like we were alluding to, is you will have to bring your own Docker file, whether you're using a base image provided by AWS or your own that you might be working with. And the essence is in that Docker file, you install whatever tertiary dependencies that aren't already supported. And then you can also, if you remember, within a container, there's the whole second part of things. So if you think of this as A in terms of the customizing that runtime environment, you also have your model/web server. And as we were talking about, most of these available or managed images, they come with these model serving engines implemented for you. So for example, Trident's implemented and all the kind of environment variables that you can tune for performance, those knobs all exist within it. But if you want to build your own custom serving stack, which I wouldn't recommend unless you're really committed for that, you can also implement this. So for example, maybe you have a Flask web server that you might be working with, and maybe you have a fast API web server or something of that sort, and you really like the way this is performing in terms of serving your model at scale or something of that sort. Then you can also bring your own model server and basically kind of fit into the different constructs that are needed for SageMaker AI to be compatible with it, basically, to be compatible with SageMaker hosting. And what SageMaker does is there's certain ports that your web server or model server needs to be listening to, and there's certain paths that you need to basically implement for for requests basically to your REST endpoint. So for a post notification, and we'll see all of this, there will be a dash notifications path. For a get/health check, there will be a dash ping path. These are essentially protocols that are compliant, that are necessary to be compliant with SageMaker hosting. So these are the two different components that you have to maybe think of a little more that you wouldn't have to if you were going the available managed image route where you just kind of pick the container. But like I said, there's use cases for this that I've seen where if you have a custom image that you need to use as the base file, and then also in more complicated use cases, if you have your own web server that you'd like to implement. So you can take A and B as kind of the kind of main reasons for why you'd go this route. A being kind of any customization, be it at the company or your individual level that you might need. And then B being if you have your own web server or serving logic that you want to work with and that you want to implement. And this might all sound a little confusing, so let's maybe hop directly into the code to kind of explain this end to end. I'm going to get out of here. I'm going to get into my AWS console, and I've created a notebook instance right here. And this notebook instance is just a T3 medium, and I'm going to work with my bring your own container approach here. A key reason I'm using notebook instances here is SageMaker Classic notebooks come with Docker pre-installed, and we're going to have to use Docker here to kind of build our image. And if you don't have too much familiarity with Docker, I'll link down below kind of a getting started guide there. But I would recommend having some understanding of that if you'd like to understand this example end to end in terms of what we're dealing with. And like I said, also check out the containers video in this playlist just to get a better understanding not of just of what Docker is, but also in specific in terms of SageMaker, how we could use it. So if we come here, this notebook's in that same repo we've been using for this entire Inference series, and you can run it end to end. What I'm going to do is I'm just going to install our usual constructs. SageMaker Boto 3 for all the execution of this workflow, Keep in mind, both 3 we can use to interact with not just SageMaker, but any other AWS services in Python. And then I install scikit-learn because for this use case at least, obviously we do have scikit-learn containers that are managed and supported, but I just want to show a kind of proof of concept in terms of how you can install a specific dependency that you might be working with or things of that sort, or if there's a certain version that an existing available image doesn't support at the moment yet. So we're going to take a scikit-learn model, a dummy linear regression model as we've been doing. We're just going to train it on some mock data. We're going to grab that serialized model artifact, which is a joblib file. And now for BYOC, bring your own container, we're going to build the different constructs that we need. So I have my notebook here, right? But I'm also going to have this directory, this container directory, and I'm going to push all of these artifacts. And remember, there's 2 things we need. We need our model data, and then we need the container, which is encapsulating our serving logic. And in this case, right, for that to build our own image, we're going to create a Docker file. And for the base image, I'm just going to use a Python 3.10 image that's compatible with scikit-learn 1.7.1. So like I said, this is once again depending on your dependencies, what base image you want to use. And if you have something that's specific to your company that you'd like to start with, you can go that route too. So I set that up. I install a few other things, and you will get into this in a little, that I'm going to need for my web server or model server that I'm implementing. And I'm going to install my dependencies that I need. So I'm going to install scikit-learn, the specific version I'm working with, joblib to be able to load that model artifact for inference, and any other dependencies I'm working with. Like I said, the web server I'm going to implement is Flask in this use case. So I'm going to have that right there. And then I set up a few environment variables. You can set up this up as the exact same. This is just basically for SageMaker AI specific constructs. And this is where SageMaker is going to load the files from. This is where it gets mounted basically, this -opt/-program path. And now what I do is, right, I'm actually going to write a few files that define my web server. So for my web server, I need to be able to kind of use whatever resources I have behind the endpoint, right, to be able to load the model and then also handle requests as they're coming in. Here, this is the default one that we've just given. And if you'll notice, I'm using an Nginx and Flask-based one for my web serving logic. You can obviously replace this with Fast API, whatever else you're working with. Like I said, if you have intelligent models or web server that you've implemented that works well with your model, just set it up. The key thing is there's a few constructs here that we have to be aware of. You have to be listening on port 8080 with your web server. So if you'll notice, we set that up. That's once again if we want to be compatible with SageMaker hosting. And you can see this in the official documentation here too for working with containers. Our container needs a web server listing on port 8080, and it needs to accept post requests on the dash invocations and dash ping path. And this is, we're going to see how we can implement this with Flask, but you can kind of mimic this and bring it over with whatever web server you're working with as well. So if I come back here, we've established our Docker file and we've used this base image. Like I said, you can customize this as needed. I'm going to create this Nginx file basically that is going to be kind of part of my web serving logic that I'm working with. And you can keep it the same, by the way, if you want to run this end-to-end. Keep this Nginx file the exact same, the serve file the same. This is just how we're going to be serving it. You don't need to think of this too much, but you can take a look at this as how you can maybe implement your own serving logic and adopt it for your use case. But I'm going to set up these Nginx and gunicorn files. You don't need to mess with them at all. The key part and the logic, and this is what you might want to adjust if you're bringing a different model, is this predictor.py. And I'm going to use Flask as my web server, like I was saying. And for Flask, if we remember, for our web server, if we remember, with our SageMaker AI, if we're adapting our own container, we need to be listening on 2 different paths, or we need to expose 2 different paths that we're working with. First is dash ping. As we can see in this documentation, we need to be able to accept post requests right here in terms of dash invocations and dash ping. For dash ping, what we're going to be doing here is, right, we're actually going to be doing a health check. So I'm going to first load my model.joblib file, and if you'll see, I've included it in the same directory as my predictor.py that I'm working with in this directory right here. And what I'm going to do is I'm going to check that that model exists, and I'm going to return a status update basically. If it's healthy, if this model object has been created and it's been loaded properly, I'm going to say we're good to go, and then that dash ping is happy right there basically. And then I'm going to come to dash invocations. And this is where we're going to get our post requests with our actual input that's coming into our endpoint, and we're going to process that. So I'll just use Flask to retrieve the JSON. This depends on how you structured your input as well. Here I'm just going to have a dictionary with input and my kind of value that my model expects. I'm going to parse it for that, ensure that I can predict it with this model inference right here. I'm going to take that model that we loaded up, our trained model. I'm going to run the predict method with that scikit-learn model. I'm just going to convert it to a list and return it in a dictionary with our output cataloged right there. And I'm going to dump that back to return. And that's where real inference serving logic's here. Obviously, this is very simple, but let's say you have a bunch of other pre and post processing files. You can have them in this directory and you can access them in this predictor.py. The key part, like I said, is once again, your web server needs to be listening on port 8080. And then it also needs to have these paths implemented, paying for the GET request, for the health check, dash invocations to actually have that request and process it and return model inference for you. This is just more of the serving file. And like I said, I made a bit of a shell script right here just to kind of create this container directory and have all these files cataloged together. So you can think of this as our model server and model data. Those are the two things we needed, right? For our container to be able to reference and point at. I've done all of that together. Now we have all of our model artifacts. We have all our resources that we need that we might be working with. Now what we can do is we can build our Docker image itself. And this is where you're going to need some familiarity with Docker. And like I said, all these Docker images, SageMaker expects them all in Elastic Container Registry or ECR. What we're going to do is we're just going to name our Docker image here. We're going to go into that container. We're going to make that regressor file, or sorry, the serve file within that regressor directory executable basically to start our web server. And then what I'm going to do is I'm going to make sure that we can create a new repository, make sure that it doesn't exist within ECR. This is basically a Docker repository managed service by AWS. I'm going to make sure that same name doesn't exist. And then what I'm going to do is I'm going to use the CLI here. You can do this via Boto 3.2 to basically create this repository with the name that we've defined there. And then it's just simple Docker commands. We're going to build this, referencing that Docker file. Remember that we've CD'd into this container where we have access to this Docker file. And then I'm going to tag that, and then I'm going to push this image basically. And once this image is pushed right into ECR, you can see this repository has been created, and you can reference this image URI right here. Just like we had in those deep learning available images when we were working with it, for example. If we go to like DGL CPU, which is what we've been using, we'll see there was an ECR image URI that we could work with, right? Here we can simply grab that same image URI, and that's essentially going to be our container. So now in reality, right, we have the same things, same building blocks that we needed when we were even using a managed image. But the extra work basically was obviously setting up the Docker file and then also your web server to kind of implement the contracts that SageMaker AI needs for you to be compatible with the hosting feature. Now that we've built this image, right, we can then return to basically the same API calls that we've been using all along. Our SageMaker model object, which just really needs that container image. You can directly plug it in here, or you can use some of these utilities, and you can replace basically the string here with your ECR name that we had here in the shell script. So right here, we defined that, right? I just did some string parsing there to be able to get that, but you can plug that in directly there as well. In this case, our model data is directly in our containers kind of serving logic itself. When you have a larger piece of model data, you probably want that in kind of another kind of model location that you might be working with, or a S3 path, rather than having it directly within the container. This joblib file is very, very small, so it was okay. But in the case of like an LLM, obviously that's not going to be the most suitable. So maybe have an S3 model path or something of that sort. I just gave that for reference there that your container can access. And then here, right, I'm going to create that model object. Then I'm going to create the endpoint config. And I think we're using a very base instance type here, C5DX large. It can probably be even smaller that you're working with. Any production variants you have, you can specify. Then I'm going to create my SageMaker endpoint. And now this is all very familiar with us. We can invoke this SageMaker endpoint with the REST invoke endpoint call. And if you'll notice, my request body is in a shape that our predictor.py is expecting. It's a JSON with the input key. So we go to regressor and we see predictor.py, right? We will see that we expect a input in our input JSON that we're parsing and that we then pass into our model. So at an end-to-end, that's how you can set up your own container. And there's many different use cases for this, right? We talked about a few. Maybe you need to build off a custom image of your own that's expected by your company or that you need to use as your kind of source image that you're building off of. Maybe you have tertiary dependencies that aren't supported, where you can maybe extend one of these available images that already exist. Or even the third one, right? There's so many use cases actually on the second one, not even as a separate point there, where you might have a lot of custom things you might want to do within a container. Sometimes, right, in a container, there might be many things that are happening. Here, this just has model inference. There might be cases where you have a Datadog agent or a Splunk agent, something that you might want for custom tracking that you might want to install in your model inference, right? So think about use cases like that, any other customization you want to introduce into your container or your serving logic. That's really where like these use cases lie. And there's obviously many different frameworks and tools out there. So it's hard to capture all of them, as many of these available images there are in terms of popular framework support. But you can take this as a reference if you ever reach a point where you need further customization. It's still possible to use SageMaker and all its goodies like auto scaling and like the managed metrics. You'll just have to do a little more work in terms of setting up your own Docker file and things of that sort. And that's often a practice that might sometimes happen in ML engineering, especially as things get more and more complicated. So yeah, I think that's at a high level is what I had for today. I just want to address more kind of like custom use cases, especially because those are more realistic. But if you have any questions, like please leave them down below as always in the comments. You can reach out to me directly on LinkedIn, Twitter, wherever it is. If you have more questions, then I'll do my best to get to them. If you enjoyed the video, feel free to leave a like and subscribe. I'll be back with much more in this area very shortly. Thank you, everyone.